Hi, this video is about creating an echo server in Java. To explain what an echo server is, we have to first know the word echo. Echo is to just say what you hear back again. So in this task, what we are going to create is, we are going to create a server. I'll call it echo server, which is going to take in any text. So let's say we are going to get a text called ABC. It comes here and we are going to echo back. Echo server says this. You're going to echo it back. So what happens is you're going to get in ABC to the echo server, and echo server is going to put an prefix saying ES to say it's said by the echo server and send it back. That's all this server is going to do. On the other end, I'm going to have some people to say these things. So those are the clients. So the first one would be client one, and I'm going to have a client two as well. Let's start with the easiest case where I have just one echo server and a client. So when I'm compiling this code, I'll be using these three terminals. The left hand side one is the server. This will be the Java program we are writing. So on the right hand side, I have two terminals for two clients. As clients, I am going to use this program called netcat, which is capable of sending out and receiving text. That is all that it can do. So when I'm opening netcat, I can first say which IP address I want to connect to. So this is the remote IP address for netcat and the remote port number for netcat, and then I can say the local port. What it means is, for example, if I think from this client, the local IP address is his or her IP address. Remote IP address is the IP address of the server, and the server will have a port and the client will have a port. Local is what's yours, remote is what's theirs. From the server side, local IP address is the server's IP address, local port is its port, and the remote is the client's information. And when we are going to talk about this, we are going to come into contact with several words. First one would be IP address. That is something you know. It's a number that is unique to a particular computer. It can be a server or a client. And then we are going to meet up with a word called port. A port is a number that can take values up to 6,000, 65,000 something, and that is unique for a process. So a computer has an IP address and it can have multiple ports which are unique identifiers for different processors. Then there is an idea called a socket. A socket is similar to a port but a little bit different. Well, let me put it this way. Now, if we talk about this echo server, it is going to have a port by the number, let's say it's port 5555. So it's always going to listen to port 5555. But this is just the opening. We can say this is just the opening, not the complete connection that it makes with the client. For example, let's say the echo server's IP address is something like 127.0.0.1. Then if you have a connection with another client, these are two-way connections. In your end, your connection goes through port 5555, and you can say the socket at this end is your IP comma this port. Even this client would have a IP address. I would say it is 128.0.0.1, something like this. So in this end, it will also have a port. Let's say it's 9999. So here the whole thing. Now here you have an IP comma port, which is a socket. Here also you have an IP and a port, which is a socket, and together all these four makes a connection. So we have to understand the differences between these words. There are ports, sockets, and connections. And when it comes to Java, there is one type of socket called server socket, which we can also call as a welcome socket. And then in Java, you have a socket as well. A welcome socket is when you just have the server and a port waiting for someone to connect. That is a server socket in Java. A socket is when this connection is already there. When you have connected, it is called a socket in Java. So this is a Java keyword. It's not a network theory kind of keyword. It's a distinction that's in Java, which makes your life easier when you are implementing code. So yeah, so now I'm going to start writing code for this Echo server. What I'm going to do is I'm going to create a class called Echo server, and I'm going to call it Echo server 1 because we are going to have multiple versions of this. So here it is. In this one, what I would first do is I am going to create a port to listen to incoming requests from clients. For that, I am going to use a server socket. So I'll go with the main method. I'll create. So when we are writing this Java code, we'll always use package classes out of these three libraries. Import. I'm going to import java.io, java.net, and these three packages. IO has input output functionality, NET has networking functionality, and util has a lot of different utilities where they didn't figure out where to put it properly, so they put everything into util. So I'm going to always import these three libraries for convenience and create a server socket. So I'll call this SS because it's a server socket, and so when I am creating a server socket, what I need is just this port number, because for the when you are inside the server, you have your own IP. You don't need that information. You just need which port to listen to. For that, I'll go with. I was going with 5555. So I'm going to create this. Then once I create this, I have certain properties for this. What are they? There are, I have a local socket address, because in this end also, in my end, I have a local address. So I will just print it. SS local socket, or else I'll call local socket address. That would be ss dot get local socket address. So this is it. Can go for a word wrap. Yeah. So this is the local sockets information. So if I run this, I'm going to compile it and run it. I'm going to compile it and then run it. So there is a unrecorded exception. That's because when you are working with these sockets, they tend to give out exceptions. Because so when you're writing code for a standalone PC where you just use the core part of Java, usually there is no chance of getting an exception except things like out of bounds. But these things can give exception. So I'll just say throws exception for the convenience of writing code, but this is not the way to do it properly. If you are writing production level code, then you have to handle exceptions properly. But here I'm just going to write throws exception because I just need the code to compile. Then when I run this, you can see it says SS. So server sockets, local socket address is an IP address here, and it's 5555. So now we have to remember these IP addresses. Since we are working on the server and the client programs on the same computer, they are going to have the same IP address. So it could be either this one 127.0.0.1 or 0.0.0.40. So it can be either of these IPs. I am not going to go into detail why we are going to have these two IP addresses. I'm going to just use them interchangeably because the reasoning behind the differences of these two are not in the scope of this video. But when we print it, we see now we already know the server's local socket address, but it's not connected anywhere yet. So then I'm thinking about connecting. But what happens is when you get a connection request from this client. So I'll use client 1 to connect. I'll use the NC program and I'm connecting to 127.0.0.1. It's port 555. When I'm doing that, I am trying to keep my local port for the client as 49s. So I try to connect, but I can't connect because I'm not running it here. But I should be able to connect this way, and I should be able to create that connection on the server end. For that, I will use a socket. I'll call it S1. It would be SS accepting the connection. And when I accept it, what should I do? Now I will have, so now I am going to have a connection with two ends. For example, system.out.println. So I can write S1 remote socket address would be as S1.get remote socket address. And I would also have a local one. S1 local socket address, which should be S1.get local socket address. So now let me run this. I'm going to compile and run it at once. Then I'm going to connect. Now you see so I should put a -p here for the local port of the client program in Netcat. I didn't put it, that was the mistake. So I run this and I put it again. Now I'll run it again for clarity. Now I'm going to run. I compiled the server and I ran it. Now I have the server socket local address 5555. Then I'm going to use netcat to connect to this server to the server's port 555 while keeping the local port of netcat client as 9999. When I do that, what happens is I get this output. S1 remote socket is 9999. So for the server, the remote address is the local remote port of the server. From, if you think from server side, it's going to be the client's port. client's local port 999. On the other hand, it's you see the 555 here. So it's clear. Now let's think about the echo part. Now in order to echo, when you do this ss.accept, we have to listen to so this connection is just giving out an byte stream. So since this is a TCP connection, the byte stream is reliable and there are a set of properties, but what it gives is a set of bytes. Now we have to turn that into something that you can print out as strings. For that, so what I'm going to type next is just Java keywords and their Java classes. This is how you do this in Java. There is no particular reasoning that we can cover in this video why you need to take this input stream and put it in input stream reader and put it in a buffered stream reader. I'm not going to go into details, but I'll just create a buffered stream reader called S1 out. So this would be S1 in. Why I would call it as S1 in is because this is what I can read from S1 into the server. So what I have to do is I have to first I have to get from S1. It has an input stream. Get input stream. I have to get it and I have to cast it into multiple different classes to get it working. First, I will have to create an input stream reader out of that. So what I do is I create a input stream reader out of this input stream. Then I create a buffered buffered stream reader. It's called buffered reader out of this whole thing. So this is the conversion that I have to do in order to get the input stream of S1 as S1 in. Then I will also have to create a S1 out. So I'll go with S1 out. This also should start from S1 and I should get output stream. And then I have to convert it into multiple classes. So I have to send this output stream into the construct of output stream writer called output stream writer. Then I have to get this output stream writer and send it to the construct of print writer. So after doing all these things, I get a print writer by the name S1 out. So when I do these things, I can read and write from S1. So I'll first read what S1 says. From the server side, what I would do is S1 in dot read line. I can read something here and I can take it to a string. Let me call this as since I'm reading or I can read it and then I can print what I read on the server side as S1 says, and I am going to print this. Then I can put our prefix to this. So when I was talking about this, I told when I get a message from the client to the server, I'm going to put ES colon and send it back to the client. So I'll do something like this. I'll append something ES this to R. Then I will print server says, or I'll say server says, and I can print it still on my echo server. Then I can send it. That would be S1 out dot the command is I think it's println. I'm going to print it out. So when you just print it out, it's not going to go there by default because of the buffering issue. So I have to run this command as well, flush. What flush does is like pushes out everything to go to the server. Now let me run this. I'm going to compile this again and I'm going to connect it. So now I got the connection here. I see those things. Now I'm going to send something from the client side. I'm going to just say hi. When I say hi, the server is going to say, server first reads this and says, so S1 says hi, and then server decides server is going to say this, and it's going to send that message. Here, you see it here. For example, if I just get rid of these system.out things in the server side, I'm not going to see any of the prints on the server. So if I just say hi, I'm not going to print out those things here. I'm just going to send it to the client, and the client is going to print it. So I think this is clear. So I can even go for a few iterations. For example, I equals 0, I is smaller than 3. If I do something like this, what it will do is I can keep on doing this 3 times. So now if I ran this and if I connect from, so something went wrong. Okay, I should write int. So for the same S1, I'm going to run it 3 times. So I'm going to compile it here and I'm going to connect from this end. Now it's first I'm going to say hi. Server sends it back as es hi. Then I'm going to say hello. It's going to go to the server and server is going to send it back with es. And I'm going to say bye. When I say bye, it's going to go to the server and it's going to send it back as es colon bye. So I think it's very clear how to work with one connection, one client. Now let's say I want to go for 2 clients. For that, I'll go for echo server 2.java. So the class name is echo server 2, and I'm going to have a main method which throw exceptions, and I'm going to import java.net. Java.io and java. So I'm going to import all these 3 and I'm going to have it. As same as earlier, I am going to have a server socket, which is a welcome socket. I'm going to have it, and I am going to have a local address for that as well. Then I am going to have S1. Now say I want another socket. I'm going to call it S2. I'm going to create another socket called S2 and print out its information. That's also okay. Now I am going to get out these input output ones for the buffer read and the print writer for S1 first. It's okay. Now I'm going to do the same for the S2. That's all. This also okay. Now say I want to do this whole connection thing. So now when I'm going to do this, what I'll basically do is I'll first read from, I'm going to read a string R1 from S1 in, then I'll append ES to the R1 and then I'll print out R1. So this works from the server. Yeah, it works from the server side. Then I'm going to do the same thing for S2. I'm going to read a string from S2, and then I'm going to print it in the console from the server side. Then I'm going to append ES to that. Then I'm going to print it on my console. Then I'm going to send it to S2. This looks like a very naive extension of what we were doing. Now let me run this. I'm going to, so now the tricky part is here my port was 999. Now here I need another port. I would be taking 9998 for client 2. Still I'm going to communicate with port 5555 in both of these things. So I'm going to connect here, compile it and get the server up and running. Then I'm going to connect with port 9999 from this client 1. You see the connection is being made here. And I'm going to connect with, I'm going to connect to port 5555 from the local port 9998. I should be getting the connection. So now if you look at the code, what happens is I am not getting this part running for some reason. It's getting stuck. But if I send a message from here, I'm going to get it back. I send a okay. I did a mistake here. I have to compile the newer one. So I compiled the wrong one. I have to compile the newer one and run it. And okay, why can't I compile it? So I have write exception here, not exceptions. So I'm going to compile it and I'm going to run. Okay, I'm going to compile it and run it in one line. And it has created the local socket. So it is basically this part has already run. Now I'm going to connect from the first client to that. Then the local and remote ones for S1 is being made. So this part has run. Now what I'm going to do is I'm going to connect with the second client. So you see the outputs here, which are these parts. And then these buffered readers are also buffered readers and write output stream writers and print writers are being taken out from the socket, the connection. Now, if I do this, I'm going to say something like hi. So it comes back. And then if I say bye from this client too, it's not going to come back for some reason. If I say bye from here, okay, there is a little bit of a caching issue here. What happens is so if I run it again and connect it here and connect this here, if I say hi here, it's working. But if I say hi from here, it's not going to work first. So I have to always say hi from the client one. Why is that? That is because this code runs line by line. So when you come here, you have to first do this and then go to this. But this is not how a server should work. A server should be able to handle multiple clients at once. And you should, for example, like let's say 2 people from your batch are going to connect to our server and you're going to do something there. But you should not wait for the first person to finish and go for the second person. Even if the second person comes first, you should give them the chance. So that is one of the problems in this approach of writing the code. Another like a doubt that you will come across would be, now in this one, the server's port is the same. The client ports are different. client IP addresses may be different, but in this case, the IP address of all these three are the same because we are using the same computer. But in that case, how can the server have unique sockets or connections S1 and S2? That is happening because every TCP connection is characterized by a four tuple, that is four numbers. There is this server IP, server port, client IP, and client port. So when if you look at the first connection, it would be 127.0.0.1, comma 5555, 127.0.0.1, comma 9999. So this is the connection one, S1. So so for the server, S1 would be just these three, because it doesn't have to care about the IP address of its own because he already knows that and it's fixed. Um, and for the second connection, it would be this. So that is how two connections are uniquely maintained without any confusion on the server side. So you can even for the same local port, if the remote port is different, you can have a unique connection without any confusion. Anyway, now the task is to create something where you can do these two things in parallel, concurrently, and without any confusion. For that, I'm going to create another class called echo server 3. I'll start with the normal things. I'll have these things, and then instead of just, I can even, so earlier what I did was this, but here instead of doing this, what I would do is I will try to accept this and make it run in parallel without interfering with the main server's work. For example, what I would do is I would have, first I'll have this connection made. Then I will create something that can work in parallel and then give this connection here. Then when the second one tries to create a connection with me, I would again create something that can work in parallel and connect it here. And I'll keep this port open for new connections. So what you have to understand is when I'm talking about keeping server port, server socket open for new connections, I'm still going to have 5555 here and 5555 here. But this whole business, the server side part that's handling the client and the client, so they are characterized by these four numbers. So it is unique. So don't get confused that I'm not going to create new ports or anything to handle this. But the connection, since it has all four parameters, it's going to be the unique one. So the port is going to be 555 for all these three things. But these connections are unique. And so since these things should run in parallel, for that we are using an idea called thread in Java. The idea of a thread is, so I'll call these threads workers. I'll call this worker 1 and I'll call this worker 2. So what a worker would do is it will work on its own without stalling the server. So I'll create a new class called worker Java and class worker. So in order for this to run in parallel, I should extend the abstract class called thread here. So that's how it works. So in this abstract class thread, which is this superclass of this, I'm going to have a requirement, an abstract function that should be implemented here called public void run. So what happens is, if I create a worker class and write anything on this run part, I can start it from any other place. For example, now let's say I'm going to create a worker called worker1, new worker, and if I write w1 dot start, what will happen is this this method, whatever you write in this method, will continue running without stalling this program. What will happen is this will start on a different thread and the rest of the program can run. For example, if I am going to have an S2 here, it's going to run. And for that, if I'm going to create a W2 and start, those things are going to run without any issue. So here, if I want to s1 dot accept something and run and start it, so the rest of the code that was originally here, so I can put this onto this run method, and I'm going to put this part to the run method as well. So if I put this into the run method, and this is just the worker class, what it will do is, so I am writing a single work class, so I'll just write s in, s out, s in, things like this. So I can get it from, I have to edit it, have something like this. So this is written in a general way for any socket for this to run. So here you see, if I just, so the whole thing works with just socket s. That is how it seems, right? So if you look at this, what's going to happen is it's going to come here, and you're going to have s1, and then if you can somehow pass s1 to w1 dot start, since it goes to this run method, you can do all these things in parallel. But the issue is, here you have a start method and here you have a run method. So it is not as simple as passing an argument from here to here. So this is this is a little bit complicated to handle, but you know how to do that. For example, what I can easily do is, I can have this s as a socket s in the class, and I can have, so how can I send this s when I'm creating the worker class? So I can just pass it here and get it inside in the construct. Socket s, so I can just get it in from the constructor. So now what's going to happen is, when I'm creating the work, I'm going to pass in s, then I will write start function here. What happens is, the run function get called and it can access the socket from here, which came in from the constructor. So this looks general enough for worker one, and for the second one also we can do the same thing, but here we have to pass s2 here. So will this work? That is the question. Now, if I'm going to run this, so this is echo server 3. Okay, I have to write the imports here because work class is also using those two. Now, if I compile it, so why isn't it doing it? worker class is here. Worker. Did I name it properly? Yeah, I have named it properly. Hmm. So okay, there is an issue here, which is we have a class worker extends. It's extends. It's not extend. It's extends. So now when I run it, uh, so there is an variable here, an small issue here. It should be S1. So we are going to get. So what this code basically does is, it is going to create the server socket and accept S1 and then give it away to worker W1 to handle. Then I'm going to go for S2 and create accept the socket, accept the connection. Then I'm going to print this information. Then I'm going to just give it away to W2 to handle. That's all. So now if I run this code, I can, okay, I have to, so run also throw those exceptions, throw exception. So the easier way to handle this would be just put the whole thing inside the try catch. Why I have to go for a try catch instead of a throws for run is because we can't change run. It should be this way. You can't pass parameters. You can throw stuff out of that. That's how it's defined in the abstract class called thread. So that's why when we had to go with this constructor passing of variables instead of passing them through run. So now it should work. Uh, equals, for three, equals, now when I try to compile this, equals server 3 is not compiling it for some reason. Okay, so the class name should be equals server 3. I have missed it somehow. We'll compile it and run it. And now when I connect here, I can connect here, and I can connect here, and I can send a hi from here first and bye from here. It works without any issue. So the idea is I can send things as I like in any order, because this the server is not going to be halted by different workers. They are going to run in parallel. For example, if I need to do this as long as, for example, if I want to do this for 10 times, I would write in I equals 0, I smaller than 10, I plus plus, and then I'll just have this here, and then I'll compile everything. And when I connect these things, for example, I'll write h1 here, h2 here, h3 here, then I'll write b1 here, b2 here, b3 here. Those things, they can run in parallel because different threads are taking care of those things. So I can do this. Then another important thing would be, now if I want to have not just one or two and a number of sockets, what would I do? So one thing I would do before that is I'll just move this printing part to the worker as well, because maybe I'll get this to the, where should I get it in this one, to the run method or the constructor. I'll take it to the constructor because it makes more sense to take it to the constructor, because this is going to just run once, and when it's running I can get these prints here, so I don't need them here. I'm just repeating it anyway, no? So this makes sense. Now if you look at this, what I'm just going to do is I'm going to accept S1 and S2 sockets for connections from SS server socket, which is the welcome socket. Then I'll just give it away for workers W1 and W2 to take care of. Now if I compile it, it's still going to work. I'll write A, B, B. You can see this local and remote socket number are printed from the workers constructor, and the other part is going from the run part. So this is all fine. Now the question is, how can I do this in a general way to last for n number of workers? For that, I'll go with an echo server 4. Echo server 4. I would just get the same thing here, and I'll call it echo server 4. And when I'm doing this, what I would do is for I'll call this SID. I'll go for 5. SID smaller than 5. SID plus. Then what I would do is I'll just have this, the whole thing inside this loop, and I don't have to call this S1. I'll just call it, I can call this by a generic name like S or W, and I can do this for here. I can go up to 5 connections, so I can connect to 5 people at once. That makes sense. So if I want, I can go for an infinity. So here also I have 5 connect. So this is I'm going to get connected to 5 clients, and for each clients I am going to go for 10 echoes. So I can go for an infinitely many number of clients and infinitely number of echoes by putting a while true loop here and a while true loop here. Because usually in a server, what you really have is an infinitely higher number of clients, because for a place like a web server, let's say Google, they don't need to serve 5 clients. They can go for an unlimited number of clients. Now we are coming to an interesting point on whether we need to keep track of these workers, because when you go through this, what you see is you create workers by the variable name W, but W is inside this loop and you can't handle them again, like you can't catch them again. Do you want to catch them is the next question. For that I'll just create another worker saying, so this new worker, I'll call it worker 2. I'll call it worker lazy, because the lazy worker needs just to finish his or her work in a small time. I'll call it worker lazy. The difference is it's not going to go for 10, it's just going to go for 2. And I'm not going to have any of these things. I'm not going to print anything inside the server side. But when I finish this, I'll just the worker will print worker stopping and end its work. So it's just going to do 2 echoes and finish itself. So now I think this is clear. Now I'll create another echo server 5 where I'm going to use these workers. So they are called worker lazy. I'm going to use them, and this is echo server 5. The difference in echo server 5 is I'm going to use this worker lazy threads for individual clients, And I wouldn't go for 5. I'll just go for 2 here. So what it will do is, if I run the echo server 5, it will just, okay, okay, where did I write worker in echo server 5? Didn't write worker anywhere. Okay, in worker lazy I have to rename the constructor to worker lazy, that's all. So I'll run it. I have the local one at 555 from the server side. Then I'm going to connect 2 lazy workers to that. And the first one is going to say hi, second, and say hi twice. And then it's going to stop. That's all. And this one I'm going to say bye, and I'm going to say bye. So the worker is stopping. So if you want to, now when they are stopping, but the problem is what happens here is, after starting these things, can you say end of program? I mean, can you figure out when the program ends? I'll write end of program here. Now what happens is, I create the server socket, then I accept clients and I give them to worker lazy threads to run in parallel, and suddenly I can go here without waiting for these things to finish. For example, if I run this again and show you, I'm running Java Echo Server 5. So I'm basically on line 8 now. Then I will connect this one. Now I have gone through the first loop, and I'll connect the client to, then I'll be out of this loop and I'll be printing end of program. So this is not what I wanted. I wanted this to end when these things finish. So because of that, now I have a small issue. How can I catch these workers and see when they finish? For that, what I would do is, I would create an array of worker lazy. I'll call that array new worker lazy array of 2, size 2. And instead of giving a variable that will disappear, what I will do is, I'll get this like this. So I'll have those variables in this array. So after this loop finish running, I'll print all threads started. They have started, but I don't know whether they have finished. Then how can I wait until these things finish? For that, so now if we think from this image, what happens is, I have this echo server code, right? I'll call it echo server 5 code. It's going to run down. After a while, I'm going to give out lazy worker. So it's AR0. I'm going to give it out. And after a while, I'm going to give out AR1 as well. Now, this is going down without any issue. What I want to do is, I want to join these things. For that, for example, I need to bring this in and bring this in. So I want to bring these two things in, and then I want to wait for them to come together. I call that joining in threads, and then print whatever the end. Then only, like after joining only, I want to end stuff. For that, what I do is, I go through another loop. So I'm going to SID loop, smaller than 2, SID plus plus, and I'm going to join them. So here I am inside this main rectangular thread. What I'm doing is, I'm joining this. So I'm doing is I'm going to wait until they finish each one of them. So this is how I start all the threads. Then I wait until they join, and then I print end of program. Now I'll run this. Now if I run this, still the first line 7 and 8 has run, and maybe line 10 has also run. I have created the array. But now when I connect the first one, what it's going to do is this loop is going to run once, and AR0 is being populated. Then when I connect this loop is going to run another time, and AR1 is also being populated, and it prints out all threads have started. Then I'm going to send messages, hi, hi, twice. So then after those two, this thread has stopped, has completed, because we are going for only 2 iterations here. So, and after that, I am getting this worker stopping output from the server side. Then when I do this twice, this worker is also stopping, and the program is also ending. So this the first one is worker stopping for client 1, then client 2, and this is the end of program. Why end of program happens is you join both the threads to end this. So that's it. In this one we talked about creating a Java Echo server, where we looked at few words like IP address, port, socket, and what a server socket or a welcome socket is, and what a socket is, and how you can have multiple unique connections to the same server port when you have different clients. And then we learned what's local and remote. What's local for client is remote for the server, and what's remote for client is local for the server. And then we use the same computer to have this server and client. So servers and clients are programs, they are not computers. You can have the same IP address. So we said that the Java programs might output 127001 and 0000 for some reason, but we didn't go into details. We said we'll use them interchangeably for this presentation. Then we wrote code. First, we wrote a server that's going to handle one client at once. Then we went for 2 clients, and we saw that there is a particular requirement for ordering in how the requests from clients come. Then we went for this idea of threads, where you can have 2 clients or 5 clients or any number of clients, where multiple worker threads are handling them. We also learned about extending this thread class to create a class that can run in parallel. And we learned that you can't pass parameters to the run method, so you have to pass them through the construct and keep them saved in the object variables to be used in the class, run method. Then after that, we wanted to finish this for the main thread to see when the worker threads finish. For that, we wrote this one, where we remembered the variables being used for threads, and then we used join. So that's the end of it. So that is the end of Java Echo Server. Thanks.